In this video, we are going to use matrices to solve systems of linear equations. Matrices and systems of linear equations can be explained using this particular problem. Solve systems of linear equations 3x minus 4y equal to 7 and 2x plus 5y equal to negative 2. There are three important matrices associated with this system. The matrices are the coefficient matrix, which are obtained by taking the coefficient of x and y. So here it is 3, 2, the first column for the coefficient of x. The second column is negative 4, 5, which are the coefficient of y. So that is called a coefficient matrix. The next one is a constant matrix, which is on the right hand side, 7, negative 2. We are combining both together and we call that as an augmented matrix. 3, negative 4, 2, 5, 7, negative 2. So we can use the augmented matrix and then try to get the solution to this equation. So if we want to solve the system, we have the augmented matrix. We can enter this matrix in our graphing calculator by pressing matrix edit. This is a 2 by 3 matrix. So when we enter that in the TI calculator, there is no bar, that line which separates the coefficient matrix and the constant matrix will not be there. We'll be entering this as 2 by 3 matrix. So when you enter that as a 2 by 3 matrix, you'll get a matrix like this. You can find under matrix math the reduced row echelon form. The reduced row echelon form is the method used to find the reduction for this using the Gauss reduction formula. So when you are trying to use the Gauss reduction formula, that RREF, you will be getting the coefficient matrix as a unit matrix. The coefficient matrix is 1, 0, 0, 1, and then the constant is 3, negative 2. So if we are trying to expand this, it looks like 1x is equal to 3 and 1y equal to negative 2. So you get the value for x as 3 and y equal to negative 2. Now if I want to solve this equation 3x1 plus 4x2 equal to 1, x1 minus 2x2 equal to 7, the augmented matrix is 3, 4, 1, 1, negative 2, 2, 7. Entering this in a calculator and getting the reduced row echelon form, we get the reduced row echelon form is 1, 0, 0, 1 with 3, negative 2. So your x1 is 3 and x2 is negative 2. So in the second example, if we have 2x1 minus 3x2 equal to 6 and 3x1 plus 4x2 equal to half, you can find the reduced row echelon form of this augmented matrix. 2, negative 3, 6, 3, 4, half, which gives us the coefficient matrix as the unit matrix along with the constants 3 by 2, negative 1. So when I distribute, I get x, 1x equal to 3 halves and 1y equal to negative 1. So your x1 is 3 halves and x2 is negative 1. Now in order to solve this equation, 2x1 minus x2 equal to 4 and negative 6x1 plus 3x2 minus 12, we need the augmented matrix. So the reduced row echelon form of that reduces to 1, negative half, 2, 0, 0, 0. Now in this case, the coefficient matrix is not a unit matrix. So when I distribute, it looks like 1x1 minus a half x2 equal to 2. And the second equation is 0 x1 plus 0 x2, which is 0, equal to 0, which is true. The second equation is true, but I'm getting only one equation which is in terms of both the variables x1 and x2. So we take a parametric representation for the second variable x2 as t. By taking the value of x2 as t, we know that x1 can be written in terms of t as half t plus 2. So This is the solution to the system. By changing the values of t, we get infinite number of solutions to this. So maybe when we graph it, we may get two lines which are coinciding one above the other. And the easy way to check whether you will have infinite number of points or not is the equation will be a constant multiple of the other. See, it looks like the second equation can be obtained by multiplying the first equation by -3. So when I multiply the first equation by -3, I get -6x1 plus 3x2. 3 times 4 is -4 and 3 is -12. So that is also a clue to say that it is the two lines are coinciding lines. They lie one over the other. They represent the same equation. Or you get infinite number of solutions, which will be the solutions for these two equations. So when an argument matrix corresponds to a two equation system ends with a row of zeros, as the system is independent, consistent, and it will have infinitely many solutions. So this equation has got infinite number of solutions. Now for this equation again, when I am trying to find the reduced row echelon form, it looks like the second equation gives me a result 0 equal to 1, which is not true. So 0, 0, 1 is the second row, which it gives me 0x1 plus 0x2 equal to 1, or 0 equal to 1, which is not true. So since this is not true, the original system is inconsistent and it has got no solution. When an argument matrix corresponding to a two equation system ends with all zeros to the left of the vertical bar and a non-zero number to the right, the system is inconsistent and there are no solutions. Let's take an application here. Suppose that the supply and demand equation for printed t-shirts are P equal to 0.7 Q plus 3, which is the price supply equation, and we have a price demand equation also. P is the price in dollars and Q is the quantity. Find the supply and demand if t-shirts are $4 each. Discuss the stability of the t-shirt market. So for the first equation, we can write Q equal to, when the price is 4, it's 4 minus 3. When Q is equal to, when P is equal to 3, we can find what is the value for Q. Q will be 143. 1.43 hundreds, everything in hundreds, so it is 143. For the second one, when I plug in 4, P is 4, my Q will be 643. The second question, find the supply and demand if the t-shirts are $9 each. So plugging in the value for P as 9 in both the equations, you get 857 and 353. So let us graph this and then find the equilibrium price. So when we are trying to graph the two equations, it looks like the point of intersection is at the point 6.5, and that is the position of equilibrium. So the equilibrium price is P. P is the x value in this case, which is, y value in this case, so it will be 6.5. And the equilibrium quantity is 500, which is the x value, which represents 500 t-shirts. Y is the price and x is the number of t-shirts. In order to have a break-even analysis, let us see this example. A company markets exercise DVDs that sell for $19.95, including shipping and handling. The fixed cost is $24,000 and the variable cost are 745. Find the cost equation and the revenue equation. So if C is the cost and R is the revenue, C will be, the fixed cost is 24,000 plus 7.45 times X, where X is the number of DVDs. The same way R will be, the selling price is $19.95, so 19.95 times X. Now entering this in the equation and adjusting the window, we get the point of intersection, and that will be the break-even analysis. So 1922 DVDs must be sold, because that is your X value, each month for company to break even. An object dropped off the top of a ball building falls vertically with constant acceleration. If s is the distance of the object above the ground, t seconds after its release, then s and t are related by an equation of the form s equal to a plus bt squared. So if I'm looking into this, I get s equal to a plus bt squared. So we can substitute the value for s, 180 feet and 132 feet. Find the residue, and here the first 180 feet is when it is from 1 second after it release. So when t is 1. When t is 2, you get the height to be 132. When you find the reduced row echelon form, the value for a is 196 and b is negative 16. So the s value will be 196 minus 16t squared. That is the answer for A. How tall is the building? So how tall is the building? You can measure the height when t is equal to 0, because that gives the total height. So substituting t equal to 0, you get s equal to 196. So the building's height is 196 feet tall. How long does the object fall? The distance will be when s is equal to 0. So you get t squared as 12.25, or t is equal to 3.5 seconds. So it takes 3.5 seconds for the object to fall. For the sake of earthquake, if T1 is the time of primary wave, which covers the distance of 5T1, if T2 is the time of secondary wave, the distance covered will be 3T2. And it says that the difference T2 minus T1 is 16 and 3T2 equal to 5T1. So using these two equations, we can easily solve for T1 and T2, and that will be the values of the primary wave travel and the secondary wave travel. But the distance covered by the wave will be, you can substitute in any one of this, 5 times that, 5 times T1 will be 120 miles. So this video helped us to understand how to solve systems of linear equations using matrices. Hope this video was helpful. Thank you for listening and thank you for watching.